Have you ever wondered why a rolling ball eventually comes to a stop? Or why a hot cup of tea cools down over time? The answers to these seemingly simple questions lie in a profound principle of physics, the law of conservation of energy. Now, this law asserts that energy can neither be created nor destroyed, only transformed from one form to another. It's a principle that has stood the test of time, backed by countless experiments and observations. Energy itself comes in many forms. There's kinetic energy, the energy of movement, which sends cars speeding down highways and birds soaring through the sky. Then there's potential energy, stored up and ready to be used. It's what pulls an arrow towards a target when released from a bow, or lifts a pendulum to its highest point. And don't forget about thermal energy. This is the energy of heat, the random motion of molecules. It's what keeps us warm on a cold night or cooks a delicious meal. Then there's electromagnetic energy, carried by light and other waves of the electromagnetic spectrum. It lights up our world and keeps us connected through our devices. And finally, there's nuclear energy. This is the energy locked away inside the nucleus of an atom. It's what powers the sun and drives the processes of nuclear power generation. But when energy changes form, it's not always a perfect exchange. Some energy is often lost as heat, a result of the limitations of our technology and the nature of certain energy conversions. But remember, according to the law of conservation of energy, that energy isn't really gone, it's just taken on a different form. This principle has implications beyond the lab. It tells us that the total energy of the universe is constant. The energy we use today will eventually end up dispersed into the universe. And it reminds us that we can't create energy out of nothing. We can only harness and transform what's already there. The law of conservation of energy also guides engineers and innovators. By understanding how energy flows within a system, they can design more efficient devices and minimize waste. This principle is at work in everything from car engines to solar panels. And in astrophysics, this law provides crucial insights into the evolution of stars, galaxies, and other celestial bodies. By studying the energy balance within these systems, scientists can learn about their origins, behaviors, and eventual fates. So, in conclusion, the law of conservation of energy is a cornerstone of physics. It touches every aspect of our understanding of the universe, from the tiniest subatomic particles to the vast expanses of outer space. As we continue to explore the cosmos and push the boundaries of technology, this principle will remain our guide, reminding us that energy is a precious resource to be used wisely and transformed with care.